Now we are going towards AC transmission line. So transmission of large block of power by AC systems of transmission has been the accepted practice at the present time. With AC transformation of voltages from one level to the other is very easily accomplished by transformers. Efficiency of large power transformer is very high, of the order of 98 to 99%, and the added to this AC is easy to generate at high voltages as compared to DC, because we have commutation problems, we have carbon bullishes, sparking, and so many things in DC generator. So now, but there are no such issues in for AC generation. And thanks to transformer, that now we can boost our low generated voltage power to high voltage as per our design and capacity of transmission line. If your transmission line is designed for 500 kV, transformer can convert the generated power to 500. If the transformer is capable to boost the voltage to 220, so your transformer can do it. Similarly, if it is designed for 132 or whatever. So this is the highest efficiency of your transformer, and the added advantages of this, that we can generate power, transformer generate AC, boost the AC, and then transfer the AC. But there are certain disadvantages. What are those disadvantages? Disadvantages are already covered in our previous slide. It means there are two conductors in DC transmission line. We are using three conductors, not only three, but even you can subdivide one conductor into 12 subconductors. It means if you have one conductor, thick conductor, you can replace it with 12 subconductors. So 12 in one phase, 12 in one phase, and 12 in third phase. So this is actually what we do. So simply speaking, the system of AC transmission line that could be used for AC power transmission lines are single phase, two phase, three phase. So most widely used in power transmission is the three phase, three wire system, while the distribution of power is through three phase, four wire system. So remember, so we can transport or we can transmit power through single phase system, as we have already discussed one simplest example based upon single phase transmission system. We have two phases transmission system. So irrespective of whether they are practically being used or not, but the most important thing is that we will be, inshallah, in our coming classes, we will be covering, we will be comparing all these systems with the simplest single two wire DC system. Two wire DC wire system we will taken as a standard model, and we will consider and compare all these systems, remaining systems, single phase, two phase, three phase, four wire system, and we will compare which one is practically suitable for transmitting and transporting power at high voltages. So this keep in mind, the transmission of power is through three phase, three wire system, whereas the power reaches at your destination or your premises as only three phase through three phase, four wire system. Fourth wire is neutral wire. So dear student, if you are transmitting power through AC systems, then there are certain restrictions, as I have mentioned, and those restrictions are already, as I told you, covered when we discussed advantages of DC transmission line. So there are certain problems associated with AC, like the necessity for the synchronization of AC generators. What do you mean by synchronization? Synchronization is your phase should be same, your frequency should be same, your bus bar voltage should be same. So this does not make any problem when you are using DC transmission line. DC transmission line, if you have certain DC transmission line, one AC transmission line is connecting power, generating power at 50 Hz, no issue. Another AC power generation system generating power at 60 Hz, no issue. So this makes no sense. There is no issue of frequency variation in DC transmission line. But when there is a AC, pure AC transmission system, So you are obliged to maintain the constant frequency. If your system, your interconnected system operates on 50 hertz, so means you must uh, operate all your power stations at 50 hertz. If your system is operated at 60 hertz, then all your power stations be operated at 60 hertz. So this is issue, but this is not issue in DC transmission line. This frequency has no concern. You can mix all the power of different generated frequency in a centralized power pool. So again, insulation problem with the cables. So if you remember, larger the voltage level, operating voltage level, greater will be the insulation issue. So you must consider. That's why I told you that if you think that transmission of power is only feasible through increasing the transmission voltage, and this only makes the sense, so we are not right. But the thing is, when we go for increasing the voltage, there will be an issue of insulation problems, heating is a problem. So you must consider all these issues. Insulator costs involved, stress on insulators. If you are transmitting power through underground cable, then the thickness of insulating material. So when we compare the cost of insulators and then the cost of the saving that we are going to save through high voltage transmission line, then there will be a certain issues. There will be a compromising situation. So it's not always necessary that we have economically possible that we transmit power through high voltage AC transmission line. So dear students, the most important one thing is that it is mandatory for AC transmission line that it must operate on synchronization mode. All the frequencies of the power station should be maintained constant, and the insulation is to be considered in mind.